Wildfires in Portugal are no longer unpredictable anomalies. They are a guaranteed annual threat. In 2025 alone, hundreds of thousands of hectares burned. To manage this continuous threat, the government enforces the Integrated Rural Fire Management System under Decree Law No. 82/2021. The law explicitly mandates that high-risk zones establish independent, guaranteed water points. Facilities cannot legally or practically rely on a connection to the local municipal grid. During a major fire event, public infrastructure frequently loses water pressure or fails entirely. Historically, the default response to these strict safety codes was simple: excavate a large hole and pour a massive concrete water reservoir. But concrete takes time. The pressure to secure legal compliance before the dry season hits often forces decision-makers into rushed, heavily compromised infrastructure planning. Building a concrete tank requires moving heavy excavation equipment onto a site and navigating months of building permit delays through the local Câmara Municipal. Once built, open-air concrete structures face the brutal Portuguese summer. The material cracks as the ground shifts, losing massive volumes of stored water to evaporation. To bypass the construction delays and evaporation losses, modern engineers and local councils are pivoting to flexible water tanks. This pivot introduces a dangerous procurement trap. Buyers often treat all flexible tanks as budget commodities, simple disposable plastics, rather than heavily engineered safety equipment. This quadrant chart maps installation speed against long-term reliability. Concrete is reliable, but far too slow. Choosing budget bags captures the speed of flexible deployment, but you sacrifice the physical reliability required for a critical fire network. A budget commercial PVC water bag looks highly appealing on a spreadsheet. It checks the regulatory compliance box with minimal capital expenditure. That spreadsheet rarely accounts for the reality of July in the Alentejo or central Portugal, where extreme heat and intense UV radiation punish industrial materials. Standard commercial plastics break down rapidly under continuous sun exposure. The fabric turns brittle and the welded seams weaken. The mechanical result is a ruptured seam that empties tens of thousands of liters of water directly into the soil, right as fire risk peaks. A dry tank paralyzes firefighting logistics. Fire trucks and helicopters are forced to travel miles away to refill, extending their turnaround times while the fire spreads unchecked. If a site has to replace a degraded budget bag every 2 years, the total cost of ownership quickly eclipses the savings captured on the initial purchase. These budget options offer the illusion of compliance. They look good on paper until a real emergency exposes the physical flaw. The alternative to a disposable bag is a heavily engineered tactical bladder, specifically systems designed by Alber's Alligator. This table illustrates the physical differences. The premium system uses an 1,100 gram per square meter PVC-coated fabric joined by high-frequency welding. This coating blocks extreme UV radiation, surviving decades of sun exposure without degrading. The closed system design isolates the water, cutting evaporation loss to zero. Installing one of these premium systems requires only a flat, smooth layer of sand. There is zero heavy excavation and no concrete foundation. By eliminating permanent civil works, these tanks are generally classified as non-permanent structures, legally bypassing months of local council permit delays. Securing this level of engineering requires a higher initial purchase order than standard commercial plastics. Instead of paying local contractors for heavy excavation, concrete pouring, and administrative delays, buyers are reallocating those exact funds into the advanced physical properties of the fabric itself. Automatically awarding contracts to the lowest bidder ignores the massive financial and operational risk of premature equipment failure. Investing in premium materials strips the budget away from temporary construction site prep and puts it directly into guaranteed decade-long operational readiness. There is a place for budget bags. If you are running a short-term construction site for 6 months, where a leak causes an inconvenience rather than a catastrophe, a cheap bag works. High-value permanent assets demand strict reliability. Consider Portugal's rapidly expanding solar parks. These remote energy sites face dual threats: external wildfires approaching the perimeter, and internal thermal runaway from their own battery energy storage systems. EPC contractors deploy premium flexible tanks to place guaranteed fire suppression water directly next to those high-risk battery containers, securing the site in hours without pouring concrete. For mayors and civil protection commanders managing difficult rural terrain, the stakes are measured in human lives and destroyed communities. Pre-positioning premium tactical bladders in forestry blind spots gives helicopters and heavy fire trucks an immediate refill source, drastically cutting their turnaround times during an active blaze. Whether you are an EPC contractor protecting a multi-million-euro private asset or a municipality protecting a village, matching the tank's engineering specification to the site's extreme risk is a non-negotiable obligation. Every water storage procurement decision should be evaluated against this 3-point fire readiness audit checklist. First, is the supply completely independent from the municipal grid? It must guarantee flow even when local utilities fail. Second, is it immune to evaporation? The water pumped in during the winter must still be there, full and clean, at the peak of the August dry season. Third, is it backed by a 10-year European warranty? That is the required baseline to protect taxpayer funds and private capital from endless replacement cycles. In a fire emergency, paying for a premium, guaranteed water supply will always be cheaper than dealing with the catastrophic loss of an unprotected facility.